You've heard of something called the multiverse, and you've heard that we may be living in an infinite number of universes. But you've also seen so-called experts go on television and say, that's total BS. We don't live in a multiverse. So which is it? In this video, first of all, I'm going to explain why nobody actually knows the answer, and the so-called experts who say they know, they're lying. They actually don't know. And secondly, and most importantly, I'm going to tell you exactly what we would need to learn about physics in order to definitively answer the question. And it's just one single solitary thing that's super easy to understand. But first, hi, my name is Daniel, and I'm an astrophysicist at UCLA. Please subscribe to my channel for more amazing content and join my fight for fair pay against UCLA, because the administrators at UCLA, just like the healthcare executives, are doing everything they can to absolutely fleece the students, take all their tuition dollars, and not pay professors such as myself a fair and livable wage for our knowledge and expertise that we offer our students. They've cheapened and destroyed our educational system, just like they've cheapened and destroyed our healthcare system. And if you're young and you're not greedy and old like Donald Trump and the Republicans, you should join our fight. Okay, so here's the answer to the multiverse thing. It turns out that the multiverse thing goes right back to the question of a superposition in a quantum state. A quantum state is one where we have an object that can be doing multiple possible things. So for example, if it's an electron, it could be spinning this way, or it could be spinning this way, or it can be spinning in a linear combination of different possible states. And if we don't make a measurement, we can't say what state it's in. It has a certain probability to be measured with a certain spin angular momentum. And it doesn't just apply to angular momentum either. It applies to energies too. We can have an atom that could have a range of possible energies, not just one energy, but a certain range of them. And then when we actually make a measurement, instead of finding it in this full range of energies, we find it in a specific energy, but with a certain probability, where if we take that same atom and we measure again, we may find a different energy. Okay, so that's the idea of the superposition. We have to write the object as the sum of all the different states that it could be found in if we make a measurement. But here's the part where we have the multiverse coming in. When we make the measurement, if you're a multiverse proponent like Hugh Everett, you say that we measured it and we found it in this state, but in other universes, it actually could have been measured to be in those other states, and those other possibilities happen in other universes. If you're not a proponent and you say that's BS, then you say, well, it just collapsed because it had some probability of doing that. However, we have no actual physical explanation for why the probability happens. We have the probability built into the equations. It's built into the matrix mechanics of quantum mechanics. It's built into the Schrodinger equation. And yet, we can't explain why God, quote unquote, plays dice. And yes, God does play dice according to the current formulation of quantum mechanics, because it's just like a dice roll that's completely random. We make the same measurement, we use the same apparatus, we make no changes, and yet we find a different energy depending upon chance. All other things could be the same. It could be the same exact atomic system in the same exact state, the same measuring apparatus, and yet we measure it once and we get a different energy than we measured it last time. And we have no physical explanation for why that occurs. That's part of the measurement problem in quantum mechanics. It's not even the full part of the measurement problem. But that's what Einstein meant when he said God does not play dice. It's that inherent randomness. You see, a fully explained theory of physics should be absolutely deterministic. And probabilities are not deterministic, they're probabilistic. What's fascinating is the wave function itself actually evolves under a Hamiltonian operator in a deterministic way called a unitary transformation. So what happens is when we take a starting state and we have it in a superposition, those actual probabilities themselves, they evolve and change in a way that can be predicted. In fact, we can even set it up so that if we make a measurement, we know that it'll definitively be in one state because we know that the probabilities of the other states could go to zero at that time. So we could set it up so that we can predict our answer at certain exact moments. But that's because of the unitarity of the actual Hamiltonian operator. But if we don't measure it at one of those special intervals and there's certain probabilities for it to be in different states, then when we make different measurements on the same system using the same apparatus, we will get different outcomes. And there's no way that we know of as of now to get rid of that. If a physicist was able to explain why those probabilities exist and what their origin is, and explain why they exist, how they exist, etc., that would answer the final question about whether or not we live in a multiverse. Because if you could prove and explain that those probabilities are just other universes where things happen and there's nothing that we can do about it, then you've proved it. But you could also say, oh, well, we actually understand where the probabilities come about. They come about because of such and such effect, maybe some quantum field effect. Who knows, right? It's undetermined at this moment. But the point is that answering where the origin of those probabilities is and why the system happens to be probabilistic is a huge unsolved question in physics. Some people, many physicists actually think that it will never be answered. Niels Bohr was one of them, and so was Heisenberg. Werner Heisenberg, convinced that these inherent undeterminate things, they were just a randomness of nature that could not be absolved, okay? And interestingly enough, some of those proponents that I mentioned, like Niels Bohr and Heisenberg, I'm not sure about Heisenberg, but Niels Bohr, he actually still rejected the multiverse proposition. So it is possible to accept the standard Copenhagen interpretation of the collapse without accepting the multiverse. There are people who have that viewpoint, and I don't want to say that it doesn't exist. But a definitive answer of whether we really do or don't live in the multiverse, you'd have to answer where those probabilities come about and solve their origin. Because right now, we just have a randomness that's inherently built into our equations, which is completely non-deterministic, and it does not answer the question then, do we live in a multiverse or not? It's an open question until that gets resolved. Well, I hope you enjoyed this video. Please subscribe to my channel for more amazing content, and I'll see you in the next one. And check out my YouTube. It's in the bio here as well. I've been making longer form videos more recently. I've got some great lectures on physics from UCLA, both teaching in person and also when I taught online, going over a lot of really in-depth problem solving for basic physics if you're interested in getting more familiarized with the starting points of physics so that you can understand this deeper stuff even more so in the future. So I hope to see you there and have a great day. Bye.